Okay, so let's go ahead and look at this practice test that I've given you, and let's decide what is the domain and what is the range. When you're given just a list of points like you are here, you're going to list the domain and range simply as that list of points, okay? When we talk about a graph and we look at domain and range, much like the bottom three problems, 11, 12, and 13, those are written a little bit differently, okay? But for domain and range, it's just literally written as a list of points here. And we're just going to actually list what they are. So what is the domain in number 1, Andy? What do you think? Perfect. You just actually list the x values, right? Excellent. Brendan, how about the range? What would it be here?
3, 5.
Good. If by chance one of these values happened to repeat, you would not list it twice. Okay, you would just list it the one time. All right? Number 2, same thing. The domain is simply going to be -2, 0, 4, and 6. Just the x values there. And then the range is going to be 0, -1, -3, and -4. And again, none of these happen to repeat, but if they did, word of warning, only list it once. Okay? Any questions on that? It's pretty basic. Okay. 3 and 4, what you're looking for is to decide whether it's a function or not. And so if I'm listing them as some points, it's different than if it was a graph. From a graphical standpoint, we can graph this particular function. Is that a function, yes or no? The black U-shaped graph? It is a function. How do I know from a graph? What kind of test do I use? The vertical line test. Okay, this one passes. I can draw a bunch of vertical lines, and it's only going to touch this graph in one place. If by chance I drew something like this, would the blue U shape be a function? No. And you can see right now that this vertical line that's already drawn touches it in two places, doesn't it? So it's not a function. So when you're talking about a graph, you can look at a vertical line test, but when they're written as points, what am I looking for? Which one? X. Good. Your x's can't repeat. So I'm just literally going to highlight my x values just to make sure that none of them repeat. Did they here?
Yeah.
The 4 repeated, didn't it? So this one is not a function. Okay? Not a function. How about number 4? And if I were you, and this is my test review, and I didn't remember that, I would write off to the side, x can't repeat, just to remind myself that's what I'm looking for. Okay? For number 4, again, I'm just going to highlight the x values. What do you think? Is this one a function, yes or no? Yeah, this one happens to be a function. Good job. Now, 5, 6, and 7 probably gave us a little bit more difficulty because you had to write the equation or the inequality of the graph that was given to us. And I have 3 different graphs, 2 of which look similar because they have the same basic shape. Which ones look similar based on their shape, based on the parent? 5 and 6. And what are those parents? Absolute value. So can I go ahead and just do this for each of those just to kind of get us started? Are we okay with where absolute value we know? Why is the 1 equals and 1 is greater than? Dotted line and shaded, and it's shaded above, so it's greater than. So I knew that's how number 6 started. Why is number 5 just an equals? Because it's not shaded at all. Perfect. So the next thing I want to look at is how did it translate? Did it move left or right? Did it move up or down? And what point am I looking at for that? The vertex. So I'm going to be looking at this point in both cases. How did it move from the origin? How did it move from 0, 0? So what I want to do is look at number 5. It went from the origin, it went left 5 and down 3. So it went left 5, down 3. How do I put that into the equation? X plus 5 goes inside of the absolute value. Good. And minus 3 on the outside. Is it upside down at all? So I don't have to worry about a negative. Is the slope different? Is it being stretched up or compressed down? I'm just looking at the pattern from the parent. Does it go up 1, right 1 each time? So it's the same as the parent. So honestly, this is the equation for number 5. And I'm done. It was only translated. It was only slid left 5 and down 3. Okay? Now number 6 has a little bit more going on with it. Okay, let's start with the translation part. Is it being shifted left, right, up, or down? Only up. Up how many? Just 1. So since it's only being shifted up, I can just put an X in there. It's not being shifted left or right, but it is being shifted up 1. Are we okay with that part? If you wanted to put plus 0 in there, that's okay. I'm not going to mark it wrong. But you don't have to. Now, is it upside down? So I do have to have a negative. Is the slope different? Is it being vertically stretched or vertically compressed? It's being stretched. By how much? This one happens to be 2. I go down 2, right 1, down 2, right 1. And so that is why there's a 2 there. Okay? We okay so far? Yes? Nice question. All right, number 7's a little bit different. Just kind of get that one listed. What is the parent in number 7? Quadratic, which means that it's going to be x squared as our parent function, our equation there. So we know it's going to be, first of all, is it being shifted left or right at all? So I don't have to worry about parentheses. Do you agree with that part? So I can just say y equals, and then I have x squared. Okay, I don't have to worry about parentheses. If it was being shifted left or right, wouldn't I have to do something like this? Or I'd have to put something inside the parentheses? But there's not, so I don't have to worry about that here. So I'm just going to say x squared. Now, is it being shifted up or down at all? What? Up 4. So I'm going to put a plus 4 here. Is it upside down? So I have a negative. And then is it being vertically stretched? Well, the parent does, from the vertex, does go over 1, or down 1, right 1, and then it goes right 2, down 4. And so that is the same as the parent, isn't it? So there is no stretching going on. So that is just the equation. And that's it. Yes, no, maybe so? Good. All right, so I'm going to pause the recording for a little bit. I want you to go ahead and look at these last 3. They're all absolute value equations. And you do, I think, have to tell me what transformations are happening. And then on the last one, these are all, I think I have cubics and cube root and square roots, right? So let me just add those here. I think this one was a cube root, is that right? And this one just was a plain old square root? Tell me, that's right? Okay, good. All right, so I want you to graph these, but I also want you to talk about domain and range, because domain and range is going to be on your test, okay? So go ahead and work on those. I'll pause the recording for a sec. So let's go ahead and look at the transformations here on 8, 9, and 10, okay? Daisy, Michelle, would you tell me what transformations are happening in number 8? Perfect. Right 1, up 2. And I'm literally okay with you just drawing arrows. To me, that means you know what you're talking about. That's fine with me. Okay? How about number 9? What's happening? Jacqueline, what do you think about number 9? Did you do number 9? You didn't do it? You skipped it? I'll skip one. All right, Tyree, help me out. Okay, so it's been flipped across the x-axis or upside down. Yes, I agree. And stretched by 4 and down 1. So we have down 1 and we have a vertical stretch of 4. Perfect. Love it. All right, how about number 10? What do you think, Brittany? Number 10? Compression. Okay, so it's a vertical compression of what? Good. That just means it's kind of like short and squattier, right? It's kind of compressed down, so the V is going to be a lot wider like that. What about the 7? Left 7. Very good. Excellent. Now, these graphs are a little bit harder. I'm going to come back to 11 because I think 11 is the hardest one, personal opinion. Okay? Let's jump to 12 and 13, and then we're also going to look at their domain and ranges. Oh, I think I went too far on this one here. All right. So in problem number 12, it looks to me like we have a cubic function. Think to our dancing. What does the cubic look like? Which one is it? This way, or is it up down? Cubic. Cube root, I'm sorry, cube root. It's horizontal, it's this one, right? Hang on, make sure I'm doing it right. It'd be that way, right? Kind of curved, S-shaped. Okay, oh, that's kind of fun. Can you do that? Can anyone do that? That'd be fun. Anyway, okay. So we have cube root. What transformations are happening? Going left or right, how many? Left 4 and down 1. Excellent. I like it if you go ahead and tell me. Helps if you write it right. Left 4 and down 1. So you're showing me that you know that. Okay? And so from the parent, that's what we're going to do. So I'm going to move the vertex. I'm going to move that 0, 0, left 4 and down 1. And then I'm going to create the same exact pattern from that 0, 0 that the parent had. And so that means I'm going to go kind of like these little diagonal shapes. And then from 0, 0, from the vertex, the middle point, I'm going to go up to right 8. And that's the point. I'm also going to go from my middle point down to left 8. Just like over here. And so then I just connect those dots. And that should be my graph. Okay? So you're using the same basic shape as the parent. I'm literally just moving the middle point. And again, it's that 0, 0 middle point that's being moved. It is okay with me if you use your calculator to double check this. Okay? The problem with relying on your calculator too much is that if I give you the graph and ask you to write the equation, that's where it gets a little confusing. Okay, so you don't want to rely on it for everything, but you can sure check it. And number 13, what's the parent function? Show me with your dance moves what this looks like, right? Off to the side, just one to the side, right? Since it's negative in the front, what does that mean? It's upside down now, isn't it? Okay? So I know it's going to look like that or something. It's upside down. What else is happening? It's being moved up 2 and right 3. So I'm going to start with the translations. Right 3, up 2. And then I'm just going, there's no vertical compression or vertical stretch. So I'm literally just going to use the same shape as the parent, just upside down. So it's going to go down 1, right 1, down 2, right 4, and then it will just continue. Okay? We'll worry about the domain and range in a minute, okay? Any questions about 12 and 13? All right, what is the parent to 11? Because 11's a toughie. What's the parent? What's the shape? Show me with your dance moves. It's not a V. It's a U. Okay, not the U, but it's a U, right? So it's a parabola shape, quadratic. So let's list the transformations. It's going down 10, I know that. What else? Left 2. And then it's also being vertically stretched by 3. And that we're going to do at the end. Okay? I'm going to start by moving that vertex point, that 0, 0, left 2 and down 10. So it's right here. It's 1 down. Would you agree with that? It's kind of off the chart a little bit, off the grid. Now, normally with the parent of a parabola, I go from the vertex, right 1, up 1, left 1, up 1. But since I am being vertically stretched by 3, I'm going to multiply the y-coordinate by 3, which means rather than right 1, up 1, I'm going to go right 1, up 3. So from here, I'm going to go right 1, up 3, and then left 1, up 3. Traditionally, the parent goes right 2, up 4. What's 4 times 3? 12, so it's going to go right 2, up 12. So from this vertex, I'm going to go right 2, up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. And then I will do the same thing and I'll mirror it on the other side. Again, if you went ahead and did this on the calculator, you could find those exact points as well if you had just plugged this in. But that's how we got there. Okay, so we're going to graph this guy. Definitely make it U-shaped. And I will kind of be a little picky on the test. I don't want it to be a point. Okay, that's a V. That's a different function. I really want it to be a parabola. All right, graphing, any questions? Because now we're going to get to the domain and range part. Yes, I want you to stretch it that way. I'm just stretching from the parent. You can stretch first and move, but it's a little bit different because I'm just relating to the parent function. Normally the parent is right one up one, right? I went right one up 3 this case because of the 3. Okay. Domain range. Let's look at the domain on all of the functions. Let's just do domain. Do any of these have what we call a domain restriction, meaning that it's something different than all real numbers? One of them does. 2 of them are all real numbers for the domain, but there's one that's not. Which one is the unusual domain one? The last one, number 13. Good. So I know in number 11 and 12, the domain is all x such that x is an element of the real numbers. I know that the domain is all real numbers. Great. But not with the last one. Why? What's different about the domain of the last one? The domain, I'm just looking at x's, not decreasing. I know what you're thinking. You're thinking that it's going down, right? That's range. I'm just looking left and right. If you look at number 12, left and right, aren't there arrows going in both directions? And if you look at 11, I know it's going up, but it's going up and out, isn't it? So it's going out in both directions too. But number 13 does not look that way, because it does what on the left-hand side? Stops. And when it stops, that means that's a starting point, and it goes off in the other direction. So where does it start? The x value. It starts at 3. Starts here. That shift tells me where it starts. So it's going to be all x such that x is greater than or equal to 3. Okay? It starts at 3 and goes on. It gets 3 and bigger. Let's look at the range now. Range, I'm looking at the graph a little differently. I'm looking up and down. Okay? So, looking at 11. Does it have a starting point, or does it go up and down forever in all directions? It has a starting point. Where's the starting point? Looking at y values now, where does it start? At negative 10. So it's going to start at negative 10 and do what? Is it greater than or less than negative 10? Greater than. So y is greater than or equal to negative 10. And then it gets bigger than negative 10. Notice that that transformation told me that. Down 10. That tells me where it's starting with the range. How about number 12? What's the domain? I'm sorry, what's the range in number 12? It is all real numbers, exactly. The range, even though it looks like it's going straight out left and right, it actually is going out and up. Okay? Slowly, but it is going in that direction. So it is all real numbers here. And then how about the range for 13? Is it all real numbers, or does it have a stopping starting point? What's the y value, Marcus, that it starts at? 2. Perfect. The y value is this 2. It starts at 2 and goes down. So the range is written y such that y is less than or equal to 2. It starts at 2 and goes down. Now on your test, you're going to have to be able to do this, okay? You're going to have to graph, find domain and range from the graph. You'll also have to find domain and range given points. They're different, so make sure you treat them differently, okay? If you flip the back over, I need to kind of give you some direction because we're going to get ready to run out of time. Please note that 14 is its own problem. How do I find f of 2? What do I do with the 2? Do you remember? Plug it in, plug it in. Okay, that's all you have to do. You're going to get one number answer. 15 is a similar type of question. It's just written differently. So let's give you some help on 15. Read it for me first. So read 15. How many answers are you expecting to get here? 3. Okay? You're actually going to do the same thing you did in 14. You're just going to do it 3 times. So what it means here is if you're trying to find the range, isn't that the output? Remember input, output? So these are all my inputs, aren't they? So you're literally going to find f of 2, f of 3, and f of -1. Okay? So I just wanted to kind of give you some, it's just written a little differently. So I wanted you to recognize that it can be written differently but mean the same thing. Okay? Now, I think on the way it's drawn on your paper, I should have given some more space there, so that's my apologies. But 16 is its own question. The graph underneath 16 does not go with 16. So if you wanted to, draw a line underneath 16, and I think you have like some kind of graph or like some coordinate underneath it, right? That graph just goes with the last 3 questions. Okay? So 16 is its own question. Are we okay with that? Because I think it was kind of confusing the way it was written on your paper. So I apologize for that. And then the graph goes with these here, where you're just going to have to draw remember what transformations are happening based on that odd shape graph. Okay? So your test is Tuesday. Okay? You have everything you need to study. The only thing that's on your test that's not on the review is graphing lines. Remember how we did that at the very beginning of class? So I'll kind of get back to it here. This guy down here, right? Can you graph that? Okay, so that's the only thing that's going to be on there that's not on the review. Good enough? All right, so you have the rest of class to go ahead and continue working on your review, and the test is Tuesday.